Okay, so we have completed question number 18. So now let's discuss question number 19. Right, so for this one, you have to determine whether the function of fx is continuous at x equals to 0. Okay, so over here, um, first thing first, we recall back on what do we mean by continuity of a function at a point. So at x equals to 0, it must satisfy this third condition, right? So f of a must equals to the limit of x approaching a of fx. Okay, so when you have it in this form, okay, so kita kena check lah dekat sini. Sekarang kita nak check at x equals to 0. So substitute 0 over here. So we want to check that f of 0 is equals to the limit of x approaching 0 of fx. Okay, so now first step kita cari f0 lah. Okay, substitute f0 over here. So when x is equals to 0, over here we have this second function. So f of 0 is equals to e0 minus e power negative 0 divided by e power 0 plus e power negative 0. So when we substitute this, kita akan dapat e power 0 is 1. Okay, 1 minus 1 over here divided by 1 plus 1. Okay, so basically kita dapat 0 divided by 2 and that is going to be equals to 0. Okay, so this is the first part lah. Kita check the left hand side of this one. Okay, and for the right hand side, so kita check limit pula. So limit of x approaching 0. So yang kita ada sekarang ni, you can check either left or right. Okay, sebab function kita yang pertama ni adalah yang selain daripada 0. Okay, so kalau you nak tulis, you nak check limit from the right pun tak ada masalah. Kalau you nak tulis limit from the left pun tak ada masalah. Okay, because that is just the same function. Okay, so let's say I write down limit of fx, x approaching 0 from the left. Okay, so the limit that we will use over here is limit x approaching 0 from the left. So that is the first function. Okay, so x over x square plus x. Okay, so dekat sini, kalau you direct substitution, kalau you use direct substitution 0, substitute 0 in x, you akan dapat 0 over 0. So that is indeterminate form. So tak boleh lah, kita kena factorkan. Okay, so we are going to have limit x approaching 0 from the left, x. Okay, and then yang sebutan x square ni lah yang kita akan factorkan. So factorize out x and then we have x plus 1. Okay, so this x we can simplify. Next line, we are going to have limit x approaching 0 from the left for the function of 1 over x plus 1. Okay, so what we have over here is when we substitute the limit, the value of x, so kita akan dapat 1 over 0 plus 1. Okay, and that is equals to 1. So therefore, we check these two values. Okay, this first one we got 0. Second one we got 1. Okay, so alright, so limit from the right pun. So yang ni first condition lah yang kita check tadi. Okay, it is defined. Okay, so second condition we check this one left. Okay, and sebab function dia adalah sama, so kita boleh state yang limit of x approaching 0 from the left of fx is equal to, sebab dia function yang sama je, this is the only exception bila kita dapat function dalam bentuk macam ni. Okay, so limit x approaching 0 from the right of fx, okay, it is equal. So therefore we can say that the limit of x approaching 0 for fx exists. Right, so it exists, but however the third condition, so this one is the second condition, right? So we check for the second condition, but for the third condition it must comply this thing that we write up here. Okay, mesti follow yang ni lah, mesti strictly. But now we can say that this value is not equal, so f0 is not equals to the value of limit for x approaching 0 of fx. Okay, so if it is not equal, so therefore we can say that fx is discontinuous lah. Okay, so it is not continuous, so it is what we say as discontinuous. Okay, at x equals to 0. Right, so this is for question number 19. So it is discontinuous. We check the three conditions and we can say that it is discontinuous. So let's check for the next question. Question number 20 over here. Okay, so if we have over here, we have this function. Now you nak cari value a and b, and it already tells us that fx is continuous at x equals to 1 over 2. Okay, so dia continuous kat situ, maksudnya dia satisfy lah the three condition. Okay, so meaning that we can write down fx ataupun f of 1 over 2 lah. Okay, f of 1 over 2 is equals to the limit of x approaching 1 over 2, okay, from the left or right, it doesn't matter. Okay, so just write down like this first. Okay, of fx. Okay, so limit x approaching 1 over 2 of fx. Okay, so first information that we can use is for this limit to exist, we understand that limit of fx for x approaching 1 over 2 from the right is equals to the limit of limit of x approaching 1 over 2 from the left of fx. Okay, ni maklumat yang kita boleh pakailah dekat sini. Okay, so for this case, kita boleh equate yang these two are equals to f of 1 over 2. So value ni, okay, so now the next information that we can use is we can make a conclusion limit of x approaching 1 over 2 from left of fx. Okay, kita boleh samakan dengan f of 1 over 2. Sebab f 1 over 2 ni, f when x equals to 1 over 2, kita ada value. Okay, that is equals to 4. So if we check for the value from the left hand side, this one, x is less than 1 over 2, our function is a minus 2. Okay, let me write down like this. Limit of x approaching 1 over 2 from the left, and our function is a minus 2x, that is equals to 4. Okay, dan kalau kita ganti masuk 1 over 2 dekat x, kita akan dapat a minus 2 times 1 over 2, that is equals to 4 over here. So substitute this value, 2 times 1 over 2, that is just 1. Okay, so a kita akan dapat equals to 4 plus 1, that is equals to 5. Okay, and for the next one, we can take the limit from the right. Okay, so if we take the limit of x approaching 1 over 2 from the right of fx, that is equals to f of 1 over 2. Okay, so if that is equals, then we check for the function. So over here, we have this function, 1 over 2 from the right, and fx is the modulus of 1 plus bx. Okay, so modulus function, that is equals to 4 also. Okay, so the only way for us to do this is kita gantikan 1 over 2. Okay, so substitute this x with 1 over 2. So we have 1 over 2b over here. We still have the absolute value sign, and that is given by 4. Okay, so now kita boleh, bila kita nak hilangkan absolute value ni, we can use the definition, which we can use squaring both sides. Okay, this one we can use squaring both sides. Okay, so when we take squaring both sides, what we will have next is over here awak akan dapat 1. Okay, so kalau kita simplify lah dekat sini, after you simplify, so sekarang ni kita akan dapat 1 plus 2 times 1 times 1 over 2, that is b. Okay, plus 1 over 4 b squared that is equals to 4 squared is 16. Okay, so if we multiply the whole equation by 4, we will have over here 4 plus 4b plus b squared, that is equals to 64. Okay, and if that is equals to 64, bila kita rearrange, kita akan dapat this quadratic equation b squared plus 4b minus 60. Okay, that is equals to 0. Okay, and then we will have two values for b minus 6. Okay, factor that out. And then we have b plus 10, that is equals to 0. Okay, so value for b, therefore we have that b is equals to 6 or b is equals to negative 10. Okay, so that is the solution for this question. Kita guna maklumat continuity, okay, on the left side and on the right hand side over here. So kita equate dulu the last condition for continuity. F1 over 2 is equals to the limit of x approaching 1 over 2 for fx, and then kita bahagi into two parts. This is the first one, to find the value of a by using the limit x approaching 1 over 2 from the left, and the second one, to get to the value of b, we use x approaching 1 over 2 from the right. Okay, so that's all for this question.